In this next chapter, we're going to strictly be talking about circles and looking at the different properties that circles contain, as well as the different lines and segments that are contained within a circle. So to start off, we need to look at a couple different definitions and different vocabulary. So first, you guys are going to be seeing this symbol, and let's call that circle C. So it will be identified in the book with a little circle and a dot in the middle and the central point. So if I call this circle C, that means that the center point is C. So it's circle C. And you guys should already know what a radius is and what a diameter is. A radius connects the central point to a point on the outside. So for example, here is a radius, and a diameter connects 2 points on the edge of the circle, 2 points on the edge of the circle, and passes through the center of the circle. So that's a radius and a diameter. So we're going to be tacking on a couple more definitions: a chord, a secant, tangent, and the point of tangency. Point of tangency. Alright, so a secant and a tangent, we need to make sure that we know the difference between those two. So first let's cover chord. A chord connects 2 points on the edge of the circle. It looks familiar, like a diameter. However, it does not necessarily pass through the center of the circle. A diameter is a chord, but a chord is not necessarily a diameter. It just connects 2 points on the edge of a circle. It could be a lot smaller, or it could be a lot bigger. And a secant. A secant is a line. So this is a segment. A chord is a segment, so it does have 2 endpoints. And these two are lines. So that is what they have in common. That means they keep going past the picture. So they are lines. A secant passes through the circle at 2 points. This is a secant. This is a secant. Whereas a tangent only passes through and really just touches the circle at 1 point. At 1 point. This is a tangent. Tangent. And that is called the point of tangency. Point of tangency. So secant passes through at 2 points, and point of tangency and tangent lines just pass through at 1 point. And so keep in mind that they are both lines, so they just keep going. Alright, so that basically covers the fundamental definitions that we will need for this chapter and section. We should be able to use these definitions with an example on a coordinate plane. So if the circle is right here, let's say the center of the circle is at 2, 2. Alright, pardon the bad drawing here, but let's say the center is at 2, 2, and I asked what is the length of the radius? What is the length of the radius? You should be able to see that the radius is 2 from the edge of the circle, because the edge of the circle would be right there on the x-axis. And if I asked for the diameter, you should be able to tell me that it is 4 units. So that would strictly just be counting on the graph, and of course the pictures that they would give you would be a little bit better. The only real math that you would have to do is if they ask for the length of a chord or something like that that was not straight up and down, you would have to use the distance formula. And here's the distance formula. First you would need the coordinates. So the coordinates of this point is 2, 4, and this one is 0, 2. The distance formula goes like this. You take the square root of the x coordinates, you pick one point to be your second point and another point to be your first point. Shouldn't matter. Alright, and you square the difference, and then you add the x's and y's together and take the square root. So let's see our example here. So let's say this is 0.1. Let's say this is 0.2. Alright, so 0.2, it's going to be 0 minus 2 squared plus 2 minus 4 squared. So that's going to end up negative 2 squared, which is 4, plus negative 2 squared again, which is 4. So that comes out to the square root of 8, and that would reduce to 2 radical 2. So that would be the length of that chord, 2 radical 2. And that's it for this section, whether this is 10.1 or 11.1.